Thank you and good morning. Again, I'm Harry Hanlon, Director of Critical Power Applications for GE. I also serve as Technical Committee Chair for the Green Grid and have been involved in a lot of different data center projects over the years. And this morning we're going to talk about why 1% efficiency matters and the impact efficiency has on total cost of ownership metrics and how it impacts in data centers. Total cost of ownership, or TCO, is a critical and well understood metric when developing new data centers. It impacts the selection in the design phase of the cooling systems and can also impact the electrical topology of the critical power system. Where the cost of the operation of the equipment as well as the initial cost is evaluated to determine which design will be used. Yet often the TCO criteria used during this design phase is abandoned during the equipment procurement or equipment upgrades. Abandoning the TCO metrics at procurement or upgrades can cost companies millions of dollars every year. Using data for a 10 megawatt data center, this session will present metrics while all stakeholders involved in a data center project should employ a TCO model throughout the process, and ways for bringing together the seemingly divergent goals of purchasing and operation teams. And there's a large case for focusing on energy efficiency in data centers. We're seeing a lot of regulations coming out by the U.S. EPA, the U.S. Department of Energy. We're also seeing a lot of impact that cloud computing is having to improve energy efficiency. And cooling is a big part of data center energy. It can account for up to 50% of the power consumed in a data center. And if you had a 50% cooling factor, meaning that the cooling was 50% of the power consumed in a data center, your PUE would be roughly 1.5 or 1.5, and PUE is a metric developed by the Green Grid. It's power usage effectiveness. It's basically the total data center kilowatt hours divided by the kilowatt hours of the IT equipment. Let's talk about TCO. Is been used in many industries and by customers to make purchasing decisions based on the true cost of ownership rather than the purchase price. And again, it's used a lot in data centers as far as in the design phase, but typically has been abandoned when making purchasing decisions. But the TCO is the sum of all your capital expenditures. That can also include installation. The operational expenditures, which include your maintenance, battery replacement for UPS, fan replacement, capacitor, other consumables within the UPS. And another key part of the OPEX that we've broken out on the right-hand side of the screen is the energy cost. So you've got the UPS losses, those cost so much, and then you've got to extract that heat out of the data center. So you're looking at several different items that you need to use to calculate your TCO. We're going to use a very simplistic straight line calculation in the examples today, but we've seen TCO models get very, very complex depending on the application. A lot of the financial or chief financial officers, CFOs, like to use net present value when you take into account the cost of money. We're not going to get that complex in today's discussion, but that's obviously something that could be used. So let's take an example, a real-world example of total cost of ownership. And this is a TCO calculator available on the internet for determining the TCO for an automobile purchase. All costs relating to owning an automobile are included, including your insurance costs, financing costs, gasoline, maintenance, etc. And you'll notice for this example, all of the entries are identical except for the vehicle's efficiency In this case, it's in miles per gallon rating. And we've made a pretty big difference from 18 miles per gallon for vehicle number 1 to 28 miles per gallon for vehicle number 2. And when we actually run this on the TCO analysis, you'll see that there's a big difference in the total cost of ownership, both on a lifetime, this time over a 5-year period, and the major part of that difference is in the fuel costs. It goes from $17,000 down to a little over $11,000 just by changing that one variable. And if you looked at it on a monthly basis, the average monthly basis, it would go from $855 a month down to $750, or about $105 a per month decrease. So, you know, this may make a little bit of sense to you, and it's something that you may have seen before. But how does this relate to the UPS and the data center? Well, one of the things that you may have noticed from the previous slide is we estimated the cost of 1 gallon of gasoline at $3.19 a gallon, which is about the average price today where I am. It varies across regions of North America, as I'm sure everybody's aware. But what if gas was 3 times today's price? That makes a huge difference, and our friends in Europe pay about 2.5, 3 times what we pay for gasoline. But all of a sudden, for the 18 mile per gallon vehicle, fuel costs increase over the 5-year period to 2 times the purchase price. So you're paying more for gas in a 5-year period than you're paying for the vehicle. That's a huge increase. And if you have the more efficient 28 miles per gallon, again, it's over the purchase price by about $10,000. And so it's a really big stretch. Now, again, this may sound far-fetched, and gasoline prices are probably not headed that direction, so I don't want to scare anybody. But if you're looking at a 92% efficient UPS, which many of them out there are, and a lot of the legacy units are 92% or lower, you can exceed the module purchase price in energy costs in as little as 3 years. So it's a big deal when you get into looking at a UPS application. So how does this impact the TCO of a data center? Here's our 10 megawatt data center. We'll assume a 10-year life. And life of a data center, we've seen TCO evaluations where they'll look at the data center life as 10 years, 15 years, even 20 years. For UPSs, most TCOs are either a 10-year or 15-year life cycle, and that has to do with lining up with battery replacement cycle, availability of parts after a 15-year period, availability of technicians that are familiar with that particular model, etc. But if you look at this particular chart, again, 10 years, 10 cents a kilowatt hour, a 10 megawatt data center, we're assuming that the UPSs are loaded 50%, so it would be a system plus system design. And the OPEX is much greater than the CAPEX in each case. But look at the difference that you see in the overall 10-year TCO as you improve the efficiency from 93% to 94%. That one drop makes a difference of a little over $1 million, about $1.5 million over a 10-year period. If you go with some of the more efficient UPSs that are available today at 96.5% efficiency, and there's several of them out there that have that efficiency today, if you look at that, it drops it to just about 7.3. So a huge drop from 12.1 TCO to 7.3. So it does make a very large difference in the overall TCO. And again, this is not necessarily a real-world example because as you stack up different manufacturers in the procurement process, everybody's going to come up with a little bit different price. But for this particular exercise, we decided to put all of them exactly the same price so that the only variable we change is the efficiency, not the cost of power, not the cost of the UPS, not the cost of maintenance, etc. So just seeing the impact of that one variable, very similar to what we did in the automobile example. Now, to properly do a TCO analysis, you need to understand what all the variables are. And some of the variables are for the site, some of them are for the actual product, and the TCOs can also include financing costs, leasing costs, even escalation factors. If you're looking at what power prices might do, it could also, you could change your load over time. But the TCO can be evaluated in straight line dollars as we are doing in this presentation, or net present value. And for net present value, you would have to add the cost of capital to be able to do that calculation. One of the more important site variables is the cooling factor, which is calculated as the kW required to power the mechanical cooling divided by the kW of heat removed. So in other words, if you require a half a kilowatt of mechanical cooling to remove 1 kilowatt of heat in your data center, your cooling factor would be 50%. Here's another slice at a little bit different data center. This is a 4 megawatt data center over 10 years. And here we've done a little bit more in the TCO model in that we have broken it up into the initial cost, maintenance costs, and then the energy cost to get to the TCO. And again, you can see the 92% UPS all the way down to the 96.5%. All of those are in double conversion. The chart, the bar on the far right of the chart, is actually what we call e-boost or eco mode. Some people refer to it now as multi-mode, where you're operating the UPS in a high efficiency mode, which gets up to 99% efficiency, and there are improved savings in that model as well. But note, in all cases except in e-boost, the energy cost is greater than the initial cost of the module. So how is this impacting purchasing decisions today? Today, most purchasing processes do not use the TCO as a criteria. Most of the time, you prepare specifications, you solicit bids, you evaluate bids, mainly based on price and delivery. A lot of data centers are built with a corporate real estate department within many organizations, or a project manager, and that individual's metrics are, can you bring the project in on time and under budget? So those are key points. Once the specifications are written, usually in the evaluation process, there's no credit given for equipment with better efficiency, whether it be a UPS, a chiller, a transformer, etc., anything that consumes energy and creates heat in the data center. And we believe that that really creates a situation where you lose millions of dollars in potential operating savings because the metrics of that individual are based solely on budget and schedule and not on any kind of operational efficiencies. And we're starting to see that change. We're seeing some data centers actually implementing and embracing a TCO process to where during the solicitation, it follows a very similar process, but during the solicitation of bids, they ask for information on the product so that they can get a very realistic TCO analysis of what the anticipated costs are of using that product. Some of those pieces of information that they ask for may include the efficiency at the designed operating point of the UPS. For instance, in a system plus system, that may be somewhere around 40 to 45%. It might be lower at 30%. In an N+1, it might be 60 or 65% of the UPS capacity. So knowing exactly what the efficiency is at the load point is a key factor. Also finding out what is the replacement cycle and replacement costs for consumables in the UPS, capacitors, fans, etc. That can also impact the TCO analysis. So again, here it does require a cultural change and maybe even some metric changes on how people are incentivized and evaluated, and that they're looking at the total operational. Some companies are starting to question data center projects as saying, hey, if I build this data center today, 5 years from now, will it still be competitive? If we're going to build a data center and run it for 10, 15, 20 years, how do I know that it's still going to bring the value to the business that we estimate today? 5 years from now, 10 years from now, is it going to add to our bottom line, or is it going to be a drag to the bottom line? So we're starting to see those conversations happen within organizations that are looking at building data centers. One example recently where a data center did use TCO to select equipment was Core Space. They made a 30,000 square foot data center in Dallas, and they used our three-phase UPS, and they're actually saving more than $88,000 a year in energy and cooling costs by using a very efficient UPS and by using multi-mode or eco mode in that UPS. So with that, we'll open it up for questions.
Here's one. Does the UPS TCO drop evenly for efficiency improvements, or do you find a declining return of savings with higher levels of efficiency improvements?
That's a great question. There are a lot of variables, and if all the other variables are the same, typically the UPS efficiency gains show a linearized savings. The issue becomes, is your cooling system linear? We have assumed a single cooling factor, but you may have a complex cooling system where at a certain loading point it operates more efficiently than a lower cooling point, and that may have an impact on your TCO. The other thing that will have an impact on your TCO is whether you use a linear constant cost of power, or whether you assume some sort of escalation, because if you escalate power, the cost savings from a TCO on efficiency will not be linear as you go over time. The other variable that we see that impacts the results could be, is your load going to remain the same over the life of the data center? And typically in a real-world example, it would not. You would assume that you would start out with an initial load and that it would grow over time. So there are a lot of factors that would really have some impact on a real-world example. The examples we used here, where we only changed one variable, such as efficiency, it would result in a linear cost savings. Great question.
Here's another question. What types are some of the major operational factors that can affect TCO throughout the lifespan of a module?
Again, the module cost and installation are one variable as far as initial cost. When we get into the life of the module, there are a lot of different factors that can impact your TCO model. One is you might want to have an extended warranty and have a warranty period beyond the standard. You'd have to include that cost. The cost of a service contract for annual or semi-annual UPS module maintenance would have to be included. And then you've got any kind of repair costs that might happen. Usually those are hard to forecast. The consumable costs would have to be included, and that's your fan and capacitors and what the interval is. probably the largest single cost in a UPS system, while not necessarily the module but normally supplied with the UPS, is battery replacement, and that can have a big impact on your total TCO analysis and the total cost when you figure a real-world example. And one of the aspects of that is the type of battery or energy storage you use. You would have a different TCO outcome for a valve-regulated product. Usually those are a 10-year battery. They last about 4 to 5 years in a UPS application. A flooded cell is a 20-year battery. It typically lasts about 8 years in a UPS application. You do have some premium valve-regulated batteries, which are also 20 years, and they also last about 7 to 8 years in a UPS application. Some people are using flywheels, and the flywheel will last the life of the module, and so that can have an impact. Typically, you have to have a very long life cycle to make the economics of a flywheel work, but there are some customers that are looking at using flywheels just because you don't have the recycling of batteries, and they're doing it for environmental purposes, not necessarily economic purposes. But those are the major things that would impact the overall cost and the TCO based on the UPS module.
Great. Here's another. Why do UPS systems use so much energy during their lifetime? Aren't they mostly backup power that is rarely used? Is the energy for trickle charging?
There are several different types of UPSs out in the marketplace. One is a line interactive version, which it actually supplements the energy and cleans up the waveform. What we have compared here today in the presentation is what's called a double conversion UPS, or sometimes it's referred to as an online UPS. And in that particular case, when it's in double conversion mode, it always takes the AC power, converts it to DC, and then reconstitutes through an inverter the AC waveform going out to the load. In that particular case, the efficiency of the UPS is less than 100%. 100% would be no energy losses through that process. Typically, the best you can get today in a double conversion mode is 96.5%, which means 4.5% of the rating of the UPS, output rating of the UPS, is given off as heat. In addition, you've got some energy for keeping the batteries on float, as you refer to as a trickle charge. Usually that's fairly marginal and doesn't make a big impact. If you have to discharge and recharge batteries, again, that's a little bit different case, but that's not a normal steady state operating condition. If you go to a multi-mode UPS where you can actually use the utility power to power the load, and most of the load going through the UPS is just in those times when the utility has an outage or an event and you're trickle charging the batteries or keeping the batteries on float the whole time, that's why you can get up to 99% efficiency. So it's about a 1%. We have found customers operating in a multi-mode or eco mode being able to use that mode greater than 90% of the time. So it gets to be very, very efficient. Now, some of that energy in the UPS, that 1% that you're losing, is actually going on fans, keeping things cool. Again, the rectifier is running to supply some small amount of power to the battery. So that's where that 1% comes from.
Great. Thanks so much, Harry. I think that's all the time we have today. You were very informative. This webinar will be recorded, and we can send everyone the recording later on today.
Very good.
Thanks so much, Harry.
Thank you for having me.
Yeah, of course. Thank you, everyone.